Well, thank you for the introduction, Jeff. My name is Reah Miyara. I'm VP of Product here at Aporia, and today we'll discuss some of the ways and maybe challenges of building generative AI applications. This topic in and of itself is probably deserving of an entire two-day conference, so let's see what we can do in 25 minutes. Quick background on me. Been working on pushing ML models to production for the past 8 years, Google, IBM, NASA, etc. But let's kind of talk about what does the generative AI landscape look like and how did we get here? So in the past 6 to 8 months, the landscape has just simply skyrocketed from companies working on text, video, code generation, image, and otherwise, right? But what prompted this explosion in the past, 6 to 9 months? Let's forget the clicker. All right, let's start with data, right? Data fuels ML models. And largely put, 80% of the world's data is unstructured, from your social media posts to Wikipedia to the history of Reddit and everything in between. Data is the fuel for machine learning models, and particularly understanding natural language has allowed us to untap this unstructured, copious amount of information. Second piece, algorithmic innovation. So in 2017, Google launched the paper, Attention is All You Need, introducing this novel architecture called the transformer. It was highly effective, much more so than recurrent neural networks or convolutional neural networks, in understanding languages and particularly the sequence of sentences. Additionally, there were major hardware advancements, from the evolution of CPUs to graphics processing units, and more specific, optimized matrix vectorization on TPUs. This has allowed us to train much more complex models at a much higher scale. And the way that large language models, or the foundation of generative AI apps, work are they're trained on tokens or parameters. And these are variables that are optimized to understand and achieve granular understanding of language. And so we've seen here an evolution in terms of the scale and number of parameters of models. Particularly, we had kind of the introduction of Elmo with 94 million, all the way to GPT-3 with 175 billion, and so on and so forth. And there's been a direct correlation between the model size and the state-of-the-art in AI performance for human-based tasks. So now you're seeing language understanding, in many cases for specific industries and verticals, actually AI is outperforming humans, right? And so all of a sudden we've unlocked this incredible capability with out-of-the-box models. And we're seeing that across the model level. If I had to bifurcate this, we have kind of the model layer where you have the bigger players, the Amazons and Googles and OpenAIs or Microsofts of the world competing in building the most sophisticated models. And then you have the application layer, which is built on top of these models. And if I had, if you wanted to take anything away from this slide, it's really deep learning requires deep pockets. What do I mean by that? OpenAI kind of publicized that they used DGX A100 chips, several of them, to train early Instruct GPT. Those are 200 grand a piece, factoring networking costs, equipment, etc. You're looking at a $100 million experiment over the course of just a few months. But LLMs, and we're happy that these big players are working on this, because all of a sudden it's exposed a low barrier to entry to actually leverage the language capabilities and understanding to build on top of that. And so we've kind of seen, one more time, this exponential hockey stick in terms of startup funding in GenAI, and particularly, probably startup companies that you've heard of or you played with or maybe were even disappointed with when you tried out their demos. But let's move on to kind of what are some of the common challenges and roadblocks? Well, when Google released Bard on a public stage, Bard hallucinated. It made a so we'll get into what hallucinations are, but as a spoiler, it actually confidently spewed factually incorrect information in front of a public audience. And as a result, the stock plummeted, particularly on the order of $100 billion. But if Google's models hallucinate, so will yours. And especially as you kind of, especially if you're leveraging off-the-shelf models, where you don't have control over the training data, over the corpus that's used to actually fuel those predictions and those classifications. Now again, it's hard to go deep in what I have left, maybe 20 minutes or 15 minutes. But I want to kind of ask the question of what would it take for you to feel comfortable and confident in releasing a generative AI application to a public audience, right? Because building a POC, there's a LangChain plugin for that. You can do it in 20 minutes. Embedding OpenAI using their awesome API into, any application has the time to value has decreased significantly, but our confidence in the performance of those models is still pretty shaky. So that brings me to kind of the first major challenge, model evaluation. Now, again, I'll spoil this by saying there is no one size fits all. And quite frankly, the difference between large language models and classical machine learning models is far and wide. But in theory or empirically, some of the challenges remain the same. What is your tolerance for a misprediction or a misclassification, right? In the case of autonomous driving, it's probably really terrible for me to identify a human as a cone. In the case of an internal support customer chat agent, I probably have a higher tolerance of making a mistake. And so when you're evaluating these models, how are you going about doing that? And I'll kind of throw in, so my marketing folks from Aporia don't get mad at me. We are, at Aporia, this is our bread and butter. Providing centralized visibility for you to be able to track these types of metrics and evaluate different models, whether it's model A versus model B, or different versions of the same model over time. Because this is not a one and done deal. It requires continuous iteration, continuous visibility, especially if you're using something off the shelf. So I have a list here of different kind of model evaluation criteria from pre-training and the data cutoffs, as well as different performance and latency and what's your cost, right? But when you're looking at the actual performance for your use case, right? The first place to start is a task-based metric. Are you trying to maybe compare a particular classification to a well-known output? Or are you looking at a summarization task or a machine translation task? And I encourage you to check out Helm. It's kind of the industry standard or academic research paper published by Stanford. It stands for Holistic Evaluation of Language Models. There is no shortage of metrics for you to start with, but I encourage you to look at this with a grain of salt, because oftentimes, right, the caveat here is not only are you evaluating based on a task that may or may not align exactly with your particular use case, but it's just one characteristic of your model's performance. Something that I found particularly useful for model evaluation is something called the chatbot arena. Because at the end of the day, who is going to be interacting with your generative AI applications. It's a set of users, whether it's internal or public-facing external users, but they will be the ones who are actually interacting with this on a day-to-day. So this chatbot arena, if you're not familiar with it, it'll actually allow you to compare, throw in different prompts, and be able to compare the output or the responses associated with Claude versus GPT-4 or Llama versus Vicuna. And human evaluation is actually a core piece of measuring the performance of your model. And you may have seen this already when you go ahead and rate an OpenAI response as better or worse than the regeneration that you requested. Or perhaps a simple binary thumbs up or thumbs down indicator. But keeping track of your users' feedback is crucial to model evaluation. And actually you can see here that we have, in addition to the task-based metrics, which you saw in Helm, you have human-based evaluation metrics, chatbot arena, as well as LLM-assisted evaluation. Now, it's kind of ironic that there's actually empirically a really decent way to measure the performance of an LLM using another LLM, right? Who's monitoring that LLM? And so, I encourage you again to kind of take these different evaluation approaches with a grain of salt and weight them appropriately for your particular task or use case. Especially, if you're in highly regulated industries and verticals. Let's continue here. So just a quick overview. Evaluation is about trust. At the end of the day, we saw a huge spike in usage for OpenAI and GPT, but and one common example of this is actually Stack Overflow. Their traffic decreased by double-digit percentages, right? But at a certain point, if your generative AI application is not establishing that user trust, the churn or the friction to churn is fairly low, right? Because there's no shortage of competitors, as we saw in the generative AI landscape. There are lots of people working on code generation and lots of new companies that will come out and work on code generation, right? And so as you work forward, one common practice or best practice is actually curating an evaluation data set based off of real production user data, something that we empower at Aporia as well. The combination of task-based metrics, user feedback, and LLM-assisted evaluation with a drizzle of human review for good measure is generally the approach that we recommend. And what kind of answer is that? All of the above, right? So it's very particular based on, again, the cost and the tolerance you have for a missed classification. Okay, now another challenge, right? And these are not, by any means, these are not mutually exclusive. In fact, they're majorly intertwined because I want to embed domain-specific knowledge in my generative AI app, but how do I know that it actually performs well, right? I'd be going back to that initial metrics pipeline. And again, that's why I emphasized model performance is an ongoing task, and it will remain an ongoing task, especially as versions evolve, data sets evolve, and your users' behaviors drift. We all remember when, maybe not when Google first came out, but when we were fairly prone to typing in movie theaters near me, right? We adapted to the search engine. And that has changed drastically with natural language understanding and understanding of complex sequential sentences and the complexities of language, right? And now we're able to actually spell out, give me an entire, 3-city itinerary for my colleagues and my offsite over New Year's, right? And so you understand that it's not just the way your LLM performs, but it's how does your user's behavior change? Now, with domain-specific knowledge, we kind of have three approaches. This isn't news. The kind of first and most obvious or naive approach is actually altering the context and the metadata. In other words, prompt engineering, right? You can adapt your prompt, and particularly different prompt types, in order to improve or at least measure the performance across different tasks. And in fact, you might have 3 or 4 or a dozen generative AI applications leveraging the same large language model. So you might have, again, a dozen different prompt types, and an important characteristic, a crucial characteristic of any good LLM observability tool is being able to surface those metrics in an ongoing manner, as well as being able to segment across different prompt types, being able to surface up insights for different user cohorts. These are our users that have said that the feedback was negative for the particular model's output. And they generally fell across prompt type category of X, Y, or Z, depending on your use case. And so prompt engineering is good for generally some sort of controlled output or classification task. For example, given this customer review, classify the sentiment. Now, a more sophisticated or perhaps more involved approach would be fine-tuning. So providing a set of domain-specific examples to help your model learn. Now, I'm going to go back to the first challenge of metrics evaluation and providing an additional emphasis on why it's important to do this in an ongoing manner, because I actually read a paper 3 days ago around how fine-tuned models with only 100 samples of a domain-specific ontology, a large language model that ubiquitously is kind of accepted as smart. It performs better on the bar than 90th percentile of lawyers, actually forgot very trivial information that was accrued during its initial pre-training phase. So fine-tuning might improve for a particular set of prompts, but again, you have to kind of constantly measure those evaluation metrics to make sure it doesn't regress in other categories. And that's what this kind of bullet around sensitivity and performance is all about. So you might supply additional information to help that model perform better, but you need to keep a holistic or a comprehensive understanding on your model's performance across your use cases. And then finally, retrieval augmented generation. So being able to provide a vector DB with proprietary knowledge from your enterprise and retrieve different documents based on some similarity score of the embedding of your prompt and context and metadata in associated documents. I think this is one of the more, I think there's a lot of hype about this, but some people jump to this a little too fast. And I encourage you to really think about, and if we had to start from the basics, what are the metrics you're optimizing for? And how does that look like before you go ahead and adopt a vector DB, invest in this level of engagement, unless your entire use case is around a proprietary knowledge base, which there are several. And of course, the bad stuff, hallucinations. So we mentioned that a really awesome LLM observability tool will not just allow you to measure a variety of task-based, LLM-assisted, and user-based evaluation metrics in an ongoing manner. But what's really important is that if you're able to monitor hallucinations, you're also able to control them, right? Because if I know that I can detect hallucinations, and they're inevitable, I have a fairly, unless I can do something about it, my confidence will naturally be lower knowing that my users will receive some sort of bad mis or disinformation. And so I think we've all seen terrible examples of hallucinations, and I won't dive into any of them. But the worrisome piece is not that it's regurgitating disinformation, but it's doing so with confidence, right? So how do you control what happens during a hallucination? Toxicity and bias, this is another very popular topic, right? So being able to really label your model or your generative AI application as responsible. So can you go ahead and ensure that there isn't bias in your model? Or at least do the best you can to ensure that it is acting fair. What about toxic information, right? So whether it's spewing things that, and again, one of the biggest challenges, in traditional or classical ML, you had a grasp on your training data. Now, even if OpenAI or Claude or Bard gave you access to their training data, it would be so vast that there is no possible way that any human could actually investigate and scrutinize it, right? And so what's in there is kind of, we're at the mercy of these models if we're using them off the shelf. And so how do we go ahead and actually prevent this stuff? Or knowing that we can't prevent everything, how do we go ahead and empower control over it? So AI guardrails, or what Aporia does with AI guardrails, is we actually use that initial challenge to empower more sophisticated features. So the combination of task-based, LLM-assisted, and user feedback across different segments and cohorts of your low-performing data allow us to detect and proactively monitor both the prompts, the input, as well as the responses or the output of your model. So this is actually done using a combination of those task-based metrics, more specific, fine-tuned, and smaller classical NLP models. And we're continuing to improve these models through open data, proprietary data, and academic research. And so what you'll see here is Aporia will actually take in that prompt, the context response. We have a plethora of different topics that you can go ahead and select and configure. You can even add your own custom topic detectors. And again, the key is not just ensuring that you mitigate these hallucinations or these toxic or bias outputs, but that you also present a way to deal with them. So what you can do is set custom actions, like pass through a positive or neutral response, block a particular negative output, or perhaps resend it for a second try using some altered prompt type. Or you can go ahead and modify the response with kind of a generic, this is an off-topic query, please reach out for additional support, right? And so having the detection capabilities and then furthermore a grasp or control over how to moderate these responses will give you confidence in being able to release that POC or transition it over to a production-ready application. Now, there's some things that are, since I created this deck, there are things that are actually, I didn't update here, including detection of adversarial inputs and DDoS attacks. I mean, another big challenge that I'm not talking about in this presentation is actually cost, right? If you're using an off-the-shelf model, particularly, whether it's an open source model that you're training on your own data, wherever you're hosting it, wherever you're using it from, it's costing your enterprise money. And that's probably a KPI that some business stakeholder cares about. So being able to not just monitor the cost and measure the cost, but also the latency of your responses, et cetera. So here's just kind of a quick flow as to how it works. In this particular case, we've obfuscated this, but this is a real use case that one of our customers was actually struggling with. Someone asked them about a particular delivery window, and the LLM responded. And in this particular case, we threw Nike and Adidas under the bus. So you imagine you're on a Nike's website and asking the chatbot, "Hey, do you do one-day delivery?" And the chatbot responded to something analogous to, "Actually, we don't support that, but I know Adidas does." That was a real use case that happened. So being able to identify things like even competitive content or things that you don't want to surface to your users that might get you in trouble, right, as the model owner or the GenAI app owner, these are things you want to have control over. With that being said, I know I'm running short on time. I'm going to skip through. This is kind of what a quick session explorer looks like within Aporia. You can actually go ahead and deep dive into individual sessions, identify kind of what are the off-topic contents that were detected using our evaluators, and view the altered responses. You can check us out downstairs. But I'll just end on the note of kind of opportunities. I think what I've seen in the past several months, and it's really taken several years to get here through that algorithmic innovation, the innovations and evolution in hardware, as well as this data abundance, is like the barrier to entry to build these apps and really leverage this knowledge has dwindled. And I think everyone here is empowered to go ahead and really apply LLMs and generative AI to make some positive impact. And so, in the next 3 to 5 years, I'll skip over these kind of example use cases. What will you build? What will you deploy? Right? What's gonna happen in 2030? Are video games and movies and personalized dreams gonna be part of our generative AI apps? Somewhat scary, somewhat exciting. Anyway, thank you, everyone.
Thank you, Reah. At this point, we're going to welcome questions from the audience. Just so that everyone can hear, we do have mic runners running around with mics so that basically put your hand up, and this is a perfect example of what will happen. All right. And hopefully the mic works. There we go.
Okay. Thank you. It was very insightful. So is Aporia used by any of the model providers, or mostly is this catered towards fine-tuned models and specific enterprises running their own version of the models? I was just curious, like any model providers like OpenAI, Anthropic, or Cohere, does anybody use this? Or what is your audience it is catered to?
Great question. A majority of our customers are actually using off-the-shelf models, and our integration is model agnostic. So it doesn't matter if you're using your own custom-built model or taking something off the shelf. We go ahead and integrate with your model and directly connect to your data lake or data warehouse.
Thank you.
Thank you for your question.
It was a great presentation. So one question about the governance and the privacy, right? So how do we if I'm a company where I'm sending data to the many clients, like hundreds of clients, right? Do I need to build a model for each of the client, or like how do we build a model in such a way that we serve many clients?
Yeah,
right?
Phenomenal question. I think the majority of customers actually leverage the same model for different use cases and applications. It's cost effective, it's much more efficient, but you're right, there is a governance and sensitivity of data question. And so the way in which we handle that is by giving the customer full control on where they store their prompt types, raw prompts, responses, etc. Generally, it's different Snowflake tables with different permissions to Aporia. So in Aporia, we have an entity called a system, or a model, and that is given permissions to a very specific set of fields within a specific table. And so you can go ahead and completely silo, think of it as different workspaces entirely.
Thank you. Looking at the guardrails perspective, so one of the questions I was asked by my clients was, in general, AI.
Can you put it a little closer?
In general, the AI happening outside the organization, what are the risks for the company? What should we watch out for?
Let me repeat the question to make sure I heard it. There's AI happening outside of the company's models?
Everywhere, right? So everybody's doing AI. So what should we watch out and protect ourselves from?
I'm sorry, I really couldn't hear the last bit.
Sorry. How do we protect the generative AI technology, the progress that is happening, and protect ourselves as a company?
If I understood correctly, what are my predictions on generative AI's impact on the company happening everywhere? I think present day, large language models are good at things that require a moderate bar of, what I'm saying is, I do not trust a generative AI application to be very precise. So when it comes to something, again, what's your tolerance for a misprediction or misclassification, like medical imaging or, God forbid, cancer diagnosis or something of the sort? That is not something that I would automate without a serious human review. So I think today, kind of remedial tasks, efficiency, productivity gains, we've already seen significant impact with generative AI applications, but I think it's how do we get to this place of confidence for those more significant challenges in the workplace? Thank you.